Hello, Mr. Eric, Mr. Ryan. How are you today?
Good.
Okay, today is Friday, yeah? Okay. Okay, so today we talk about finding two strings, special strings in a list of strings. Like
I can make an earthquake. Whew.
no. Look, A B C D, A B C C, A C D E, F A G B G H. Okay, so you need. I give you a list of strings which has the same size.
Does it have to have 4?
Same size, yes.
Does it have to have 4?
No, it could be 5 or 6, but they are all the same size, right? Okay?
They all have 4 letters.
Or 5 letters or whatever, okay?
Okay.
So I want you to tell me that if there are 2 strings in a list that only has 1 letter difference. For example, A, B, C, D and A, B, C, C has only 1 letter difference. Yeah? Got it? So you need to tell me it's true. Okay, if this becomes D, B, C, C, then you need to tell me false because you can't find any string, 2 strings in the list which only differ by 1 letter, 1 index. Okay? Does it make sense? Or how can we do this?
Oh!
How can we do this? The first thing to think about is
Brute forcing!
how do we brute forcing?
Checking every possibility.
Checking every possibility. How can you be specific? How to check the possibilities? How do we check? We want to find out if there are 2 strings. So how do we find out if there are 2 strings? What?
We check every 2 strings.
Yeah, and if there are n strings, this take the brute forcing of n strings. Checking every 2 pairs takes how much time? To brute force these pairs. What are those? O n what? The complexity of brute forcing the n.
O-N square.
Yeah, well done. O n square.
That's my favorite now.
Okay, and then
Why do you have a space using?
not yet. So we know O n square to brute forcing each pair, 2 pairs if they are n string, right?
O-N square.
So how do you
O-N square.
how do you check if there are given 2 strings if they differ by 1 characters?
Oh, you just go like this.
Go through
And
it.
then if it's different,
Then you return, right? No. If they're different, you count. You add 1
yeah.
and answer add 1, and then you
Yeah,
keep going, right?
Only the maximum
Is
is
1.
1.
Yeah, it's not maximum. The minimum, the maximum of 1. So it has to be exactly 1 difference, right? So you actually count the difference by going through, right?
Wait. What if 2 are the same?
Then it's 0. The difference is 0, and it's not the same. So right?
So
false. So basically, we want to iterate each character, compare character by character, and increment the counter if they are different, right? Yeah, and then as I said, if they are the length of each word is L, then you need to take OL time, right? Yeah, does it make sense? Given 2 L strings, so the overall complexity for these is ON squared times L. Does it make sense?
does it need to dot?
Yeah, does it make sense? Yeah. Is it clear?
That's quite slow.
Yeah, quite slow. Because but at the beginning, let me repeat. At the beginning, we need to brute forcing each pairs. That would be ON squared. And for each pair, we need to take OL time to check each character. Yeah, to check if character to find out if there are only 1 difference. Right? Like overall complexity is ON squared times L. Can we do better? Maybe we can. Yeah, maybe we can. Yes, we can. Okay.
Of course.
So how
How
can we do this? Make it better. We can use what?
Notebook.
We're done the notebook. Why we want to use the notebook? The hash set notebook or hash table? Yeah, hash set.
.com.
Hash set.
.co.uk.
Hash map. Okay. Yeah, hash set.
.co.uk.
Okay. So how can we do this, Eric? So look at the ABC. Eric. So
What's hash set now?
the notebook has 2 kinds, hash set or hash map, okay? Right? The hash set in Python is set, yeah? You're using this. Hash map is the dictionary, remember? The
Dictionary.com.
key value pair, yeah? You can say, okay, what's key value pair? Eric, 8. Ryan 7. So if I want to look up the value Eric, I can just say look, okay, the age is Eric, look. What's the hash set? Let me hash set Eric, look,
Yeah.
A equals set, yeah? And then you can say A dot
I mean,
add
like this.
add Eric.
Yeah.
Eric, look at this, add Eric and A
Yay!
dot
I'm an
add
anagram with rice.
Ryan, okay? You can, this is set, and then you
I'm
can
an
say,
Hey, this looks like an R.
okay, and you can say, look, mommy, is mommy in A, that will return false, right? Because it's not in the in the hash set. You can say Eric in A, then return true, right? Because we just added. Yeah. So that's O1 constant lookup time, right? You have notebook. You just look at it instantly. You can find if they're Eric or Ryan on the notebook. Yeah. Does it make sense? Yeah. Hash set. Do you understand? Yeah.
Yeah.
What's this key value pair? Then you'll
I'm
be
an
like, look,
I'm
A.
I'm an anagram with rice. You can just
Yeah.
say
Look, Eric.
A.
You can say this, Eric.
yeah.
A equals
Rice.
dictionary. You can do this dictionary, right?
.com.
Dictionary. Then you can
.co.uk.
say, you can say, look, A Eric equals A, and A
Ooh.
Ryan. Look, it has key. This is key, and that's the value 7. And then I can say I can look up this value A Eric, then you could return A. A Ryan, you could return 7. Does it make sense? So this is O1 constant. It has key value pair. But this one is only have key, it doesn't have value. It's a collection. It doesn't have order. It has collections. Yeah. That's all called notebook. Yeah. Because you can have a key value pair on your notebook, or you can just write the name on your notebook. Right. These both are okay. Okay. So coming back to this question, what do we need to put in the notebook? Look,
The first one.
Eric, look.
No.
Eric, we don't want to put this in a notebook because it doesn't help, right?
See.
Okay, it doesn't help. Why is that? Because if we put this in a notebook A B C D, we can only check if they are same string A B C D in the notebook, right? But we want to find out if they are string which differ by only one difference. So what does it mean? So how can we solve this problem? A B C D. How many variants differ by one character?
What?
How many variant? How many possibility if differ by one character? What are those?
A, B, C, D.
No, what are the characters? Can you list the example which is different than this one?
Oh, okay. So, there can be multiple letters of changing for one.
No, just one letter difference. What are the one different? Can you give me an example which is one different, one letter difference?
Like
Then
B, B, C, D.
well done. So the first one is not. It's different, right? Yeah. So basically, you'll be B C D something B C D, right? Or A something C D, right? Or A B something D, right? Or A B C something, right? Alright? Yeah. How about if I make these different bits a common letter like question mark, and if I put these in a notebook, yeah, I put these 4 variants in a notebook. So the next time when I go to here, it has also 4 variants, right? Then this will become A B C question mark, right? Right? What's this? A B C question mark here. A B C question mark. Yeah, we found a match. What does it mean? It means these two differs by only one character. Does it make sense?
Yeah.
Do you understand what I'm talking about? Yeah?
Yeah.
This is very elegant, right?
Yeah.
Okay, so can you explain to me why?
Oh, cause so you do like if it's one letter difference, that means if A has to change, or B has to change, or C has to change, or D has to change. So that means it can be question mark B C D, A question mark C D, A B question mark D, and A B, or A B C question mark, and then you hop on to the next one, and there's A B C C, and that's also match up with A B C question mark.
Okay, so because we already put these 4 variants in a notebook, right? Yeah? And then we can look it up, right? And if we find it, we found one match, right? Does it make sense? Yeah? Otherwise, we'll put it there. So that will work, okay? Let's do this. That will work.
Dictionary.
Define, let's just do it, check. And then we have these words, okay? And then,
Color.
okay, wait.
Color.
Okay, so now we have this data, which is the set, yeah? We just need to store these variants, yeah? Remember the variants. Okay, look, Eric, for word in words, yeah? So these words will be ABC, something like that. This is the word W, yeah? W will be.
W.
Okay, so now we want to store the variants. We want to get a variant. How do we get a variant? Replace it with question mark.
Yeah.
And
For every character.
yeah, look, how do we do this? For I in range length W. Yeah, so we index it, and then we want to look at the currently I will be indexed for this one. So we want to replace this one. Yeah? So look, the variance. Let's do it variance. Okay, V equals look at W. Yeah, I want to get I. Okay, so I want to get the I want to get the, for example, look here. I is here. Right? I want to get all the characters before I, which is this part. Yeah. And this bit B, I want to replace it with question mark, yeah? Question mark, yeah? Yeah? And then now I want to get all the characters after. So what's this? Plus W what? What's this? This is I, and then what's this?
I plus 1.
I plus 1 to the end, yeah? Column. This is beginning to the I, not including I, yeah? Does it make sense? Okay, then if V in data return what? V.
2.
Yeah. And then if not, then we can.
Return false.
No, yeah. Why is it return false? We want to put it in the dictionary.
Dictionary.
Data dot add what?
Dictionary.
Data dot add what?
Dictionary. .com. Data. W.
What? W is the current ABCD. We want to add the variant with the question mark. I is an integer. We want to add what? We want to add V because next time we want to check if it's in the data. And what's one thing missing here?
Cash.
No?
Return.
Return what? Yeah, if no, there's nothing we can find, then return what?
False.
Yeah, false here.
Knew it.
Okay, what's this part?
Come on.
What's this part? What's this part?
Are they 2?
Yeah, 2. If what, then do what? Yeah, we want to check if V in data.
Then done.
Not yet.
Then.
And think about the complexity, okay? If what? We want to check if V is in data, then return true, right? I just told you. Come on.
If V is in data,
Yeah.
return true.
Well done, Didi.
I heard.
No is in data. There is no is in data.
If V if V
In data, yeah.
that don't make no sense, but we like it.
Data. Column.
Data column.
What?
Return true.
Okay, well done. Okay. What's the time complexity?
Open.
This is,
N square. O N square L. Hey, I'm a koala.
O(n) square. That's the previous brute force. Look, this is n times, right? O(n) here.
O N cubic.
And then this is air here. The length will be air, right?
O N log N. O N log N. O N log N. O N plus L.
Why is it plus? This is together. It's not separate. It's
O N times L.
yeah. What's the space complexity?
O1. N.
Well,
O N times L.
yeah, well done.
Knew it. Who cares?
Here, they're using the data, okay? Ryan, using the data. If you see something using something, that's not O1, right? Ryan, does it make sense? Okay, that's it for today.
Bye. Look
No.
at this computer and look at this stuff.
Okay, that's it.
Yeah.